Hello, and thank you everybody for joining the fourth webinar of the day in the CREST intelligence-led penetration testing webinars. So thank you. And so I will be handing it over to your presenter in a short while, but who is Paul Laîné from Context Information Security, which is part of Accenture Security. And today Paul's going to be talking about DynamicWrapperEx, registration-free in-process COM automation server. And I have had a brief look at this presentation yesterday, so it's really interesting. So it's a good thing that you've all come on today to listen to Paul. So just before I hand over to him, I would just like to say that you have got an opportunity to ask Paul some questions at the end of this presentation. For those of you that have been on GoToWebinar before, you know there's a question pane, and for those that you haven't, you may see in your pane just down by the side or along the top, depending on where it is, there is a button which says questions. Please feel free to type your questions in there, and we'll get as many asked of Paul at the end of this presentation that we can. So with no further ado, I'll hand over to Paul to introduce himself. So thanks, Paul.
Yeah, thank you, Debbie. So first of all, thanks CREST for hosting me, and thanks to all the previous presenters. Quite a lot of information and interesting information have been shared this morning. So thanks for that. So as Debbie mentioned, my name is Paul Laîné. I'm working for Context Information Security, which is now part of Accenture Security. And nowadays, I'm working mostly in simulated attack, red team operations, and capability development, where I'm doing research and development and building all the tools and the malwares and payload that we're using during our red team engagements. So DynamicWrapperEx, this is a tool that I've been writing over the last weeks. And as we will see, this will allow a user to be able to execute Windows APIs from a scripting context, so from VBS or JScript. And the main objective of this presentation is not to fully go through the implementation, because there's no time for that, but it's rather to try to explain all the underlying technologies that are in use. So it's to demystify how it actually works, and subsequently, how you can create your own if you're willing to. So to do that, I'm gonna first try to explain what's DynamicWrapperEx, so why I've been building that and what the actual origin of the technique. Then I will try to cover a bit of the origin of COM, of the component object model. Then I will try to explain what's a COM interface shortly and the actual memory structure of a COM interface. After that, I will go through an automation server and automation controller, what they are, and how we can leverage this technology in order to actually execute Windows API from a script context. Following with a brief, go through what's a calling convention and the difference between x86 and x64 architecture on an Intel 64 processor, and why it's actually important in this case. And then I will go through the side-by-side assembly technology and how we can leverage the side-by-side assembly technology for registration-free COM activation. And I will finish with some of the limitation and operational security consideration while using this tool. So first of all, the objective of the tool is clear, as already mentioned, is the way to actually execute arbitrary Windows APIs from a scripting context. So it's going to be VBS or JScript in this case. Why not VBA? Well, just because VBA is already offering the ability to call Windows APIs. The reason why arbitrary is between stars is because there's some limitation that will be covered at the end of the presentation. But the overall idea is if we do have this ability to call Windows API, we can drastically improve the capabilities of the first stage malware that are going to be delivered through a phishing campaign, for example. So there's some classic HTA with JScript or VBS code that can be used for stage 0. And if we have this ability to call Windows API, we can do pretty much whatever we want on the system. So the idea is not new. The actual ability to execute Windows API and execute exported functions from DLLs is not new, because I mean, a long time ago in 1998, Jeff released a blog post in which he explained how he wrote a tool called DynamicWrapper, which was actually doing that, offering to programmers a way to call from the VBS functions and export the function from DLs and subsequently Windows APIs. Later in 2008, Yuri Popov actually released a tool called DynamicWrapperEx, which has been fully rewritten in Go assembly. But the very important thing here is that Yuri never provided the source code. The only thing he provided is a compiled version of it, which is a pretty big problem in our case. And the reason is because, you know, some threat actors and all the red teamers have been using, and I believe are still using, the DL, the compiled DL from Yuri. So on the red team side of thing, we have the Quadratic Thievery framework. But on the threat actor side of thing, we have a couple of ransomware and all the VBS loaders that have been using this technology. And the problem is that they are all sharing the exact same DL because it's precompiled. And because they're sharing the same DL, they're sharing all the same signatures. And this is pretty bad because nowadays, if you drop into a disk DynamicWrapperEx, it will almost instantly be detected by most of the antiviruses. So the technique is pretty interesting, and I believe this is quite a good way to achieve first code execution on a system. So the way to achieve that is just to create our own. And to create our own, we first need to fully understand how it actually works. Another motive is that I wanted to find a reliable alternative to the .NET to JavaScript tool, which, don't get me wrong, is a pretty awesome tool, but it's pretty old. It's from 2017, and therefore they all do quite a lot of signatures. So let's talk a bit about COM. So COM is pretty old because the actual origin of COM is from the necessity to find a technology, an inter-process communication technology, in order to share data between two processes, which is something that Microsoft provided in 1987 with DDE, Dynamic Data Exchange, and Clipboard, which was pretty messy because DDE is actually relying on the window thread messages and message queue. So it's quite heavy because both of the processes need to register to notification, and then they need to implement their own message pumping mechanism to get the messages, and based on the message type, they need to do specific actions. On top of that, there's also another limitation is that DD is using the global atom table on Windows, and that means that every single messages are limited by 255 bytes. So if you have large data to actually share between two processes, that's going to take a while. So this is for this reason, and I believe for other optimization reasons, that in 1992, with Microsoft Windows 3.1, they released OLI, Object Linking and Embedding. And the primary design of OLI is to be able to create compound documents. And the idea behind compound document is pretty simple, is the ability to create one document that is that contains other documents. And this is possible by abstracting the graphic interface around a specific data. So that's going to be the ability to insert an Excel spreadsheet within a Word document. And when the Excel document is updated from within Excel, the data will automatically be updated in the Word document. Problem with OLI, the first version of OLI actually, is that it was internally using DDE. So again, that was quite messy, and the implementation is pretty bloated. So that's the reason why in 1993 they almost revamped everything to use components, which is actually the first appearance of COM at that point in 1993. But over the years, the terminology of OLI slowly faded away, over the years to actually let place to COM in 1995. So what is COM? So it's interesting because COM is pretty old, as I was just see that, but it still feels like there's a large veil of mystery around it. But COM is actually a standard, and this is actually a standard that can be used to fix a massive problem, which is applications that have been designed in a very monolithic fashion. And the problem with monolithic application is every time you want to add a new feature, every time there's a security issue, or a bug or something, depending on the size of the code, that's going to be extremely difficult to find the actual origin of the problem. So by being able to write component-driven application, you have different modules, and every time there's a problem, you're able to identify in which module the problem is, and that's going to drastically increase, the speed of identification and fix of a problem or development of a new feature. So this standard is actually an interface technology, because as we see in the next slide, COM is all about interfaces. And the very important thing here is those interfaces, although as we'll see, will offer polymorphism and encapsulation possibilities which are incredibly powerful in terms of flexibility, and in terms of we're going to be able to customize our application without having to write very bloated and difficult code. And although something super important, very reusable code. And it's language independent, actually. So because it's a standard, there's no specific language you can use. You can use pretty much any procedural language. And actually, for a long time, some components have been written in Java and not necessarily in C and C++. Final thing about COM is they although created DCOM, which is distributed COM, which leverage the DC MSRPC protocol, so the distributed computing environment and Microsoft Remote Procedure Calls, and all that have been developed in 1996 in order to offer the ability of application to use components that are located over the network on a remote system. And final thing about COM is when we are talking about COM, we are talking about, when we are talking about an application using a component, we're talking about COM client. While when we're talking about a component, this is a COM server. Right, so let's have a look and define what's an interface and what's a component. And here it's important to understand that an interface is basically the glue between component and clients. And this is, because it's a standard, COM is a standard, this is actually a memory structure that will be used to define the shape and a behavior, but there will be no implementation details at all. It's up to the developer when creating a component to actually provide the implementation of an interface, which means that a component is actually the implementation of one or multiple COM interfaces. So this memory structure can actually easily be obtained by compiling a pure virtual C++ interface, which again is just an interface with no implementation details. And we can see on the right-hand side the actual representation in memory, let's say, of such memory structure. So we have a pointer to a virtual table, which is nothing more than just an array of function pointers. And when they're going to be implemented, they're going to point to a class that actually derives from the interface and provide the implementation. But that's not the only thing. There's also a very important thing, which is the actual unknown interface. In order to have a COM interface, every single interface must derive from the unknown interface. And the reason is simple. Well, it's difficult and simple in the same time, but it's because of polymorphism, which from Latin, from polymorphos means many forms. And the idea of polymorphism in programming is this ability to be able to use the exact same operation, so let's say the exact same code, against multiple different types and classes. In this case, we're going to have different types because we're going to use different interfaces and all COM components. So if every single component and interface is derived from the same interface, here high unknown, that means we're going to be able to use the exact same code to manipulate all those components. So if now we have a look at the unknown interface, we can see that these three functions that are defined. So this current interface, which we'll see in the next slide, and addref and release. So addref and release are extremely important because components are responsible for their own lifetime. So as a client, we cannot delete, or actually not in a safely manner, we cannot delete a component because, I mean, in this project, we're only using an in-process server, which means that the actual component will be loaded into our own process and we'll be the only one to use it. But if you think again about a DC MSRPC, or if the component is the remote process, we don't have an easy way to figure out how many clients are using it. So if we kill one, we potentially jeopardize the execution of another process or another program. So the reason why components through the address and release are merging their sum through reference counting their own lifetime. Now regarding the query interface, and this is actually a very important one, if not the keystone of polymorphism here, is that due to encapsulation, which means that an interface that derives from another one, that potentially derives from another one, and so on and so forth, we need other client, as the actual client, the ability to identify what is actually offered, what is actually exposed, and what we can actually do with what we are manipulating. And this is what we can achieve with query interface. So GUID, global unique identifiers, are used to identify interfaces and classes. They're not using names because, I mean, for many obvious reasons, but if two developers are using the exact same name, that's gonna definitely lead to problems. But now if we're using global unique identifier, we ensure that they're gonna be, like, as the name implies, a global unique identifier for the interface of the class. So by providing a global unique identifier, in this case by reference, the actual implementation of the interface will dictate whether or not this is something supported. And if this is something supported, we're gonna just return a pointer to it. If it doesn't, well, we're just gonna return an error, and the client gonna have to work on that. So now let's talk about automation, because this is actually the most important part here, and this is where we're gonna start, like, actually understanding all the tool, what the actual tool is leveraging and using. So the thing is, like, when we are in a scripting context with VBS and JavaScript, for example, we don't have header files like in C or C++. So we have no declaration of the interfaces, and therefore we don't understand, we don't know at runtime, so when we're executing, what is actually offered by the object. So we don't know what the functions and property we can access, and subsequently we cannot execute them. So OLI automation is actually providing a new way to communicate with COM components by offering a dynamic way to figure out what is offered, and then to execute the function or read or modify a property if this is some a property that you want to work on. So obviously it's been designed for scripting languages, and the particularity here is that instead of only deriving from the unknown interface, components will have although to derive from the dispatch interface, which dispatch although derives from unknown. It may be a bit confusing, but in the next slide will make a bit more sense. So the other bit with all the automation is when we are using automation, we're not talking about COM client, but we're talking about automation controller, and we're not talking about COM server, but instead we're talking about automation server. But this is fundamentally the exact same thing. So let's have a look at the high dispatch now. So the high dispatch interface is deriving from the high unknown, and actually the virtual methods have been hidden here. But there's 4 functions. The first 2 ones, getTypeInfo count and getTypeInfo, I'm not going to cover that here because they're used to check whether the actual component provide type information and to get the type information, which is also another interface. So I'm not going to cover that here. Instead, I'm going to focus on the get IDs of names and invoke functions. And they are pretty interesting for 2 reasons. Is because they will always do introspection and reflection. So in programming, there are 2 pretty interesting and complex IDs, but we can easily define that by, introspection, we can easily define that by the ability to identify what is offered. So understanding at runtime what the function that I'm offering and what the properties I'm offering and I'm exposing. And reflection on the other end will be used to actually modify those properties and modify the actual object. And this is what we're going to achieve with get IDs of names and invoke functions. So to understand how we can do that, we can see here, we have a quick example of like a JavaScript file where we have a DynamicWrapperEx object, which is the automation server. And from this automation server, we want to execute a function called DWT-register, which has 2 functions, which has 2 parameters, sorry. And here, as shown here by the debugger, so it's a screenshot from Windows Debugger, we can see that the GScript automation controller will first call the get IDs of names with the name of the function, here DWT register. And what the get IDs of name will do, it will just like simply go through an internal table that lists all the function names and dispatch IDs and return the dispatch ID corresponding to the name of the function. And a dispatch ID is nothing more than just like an integer, like a unique identifier that is only meaningful for the automation server, that is used to identify a function or property. So if no error are returned, this dispatch ID is then used by the automation controller to call the invoke function from the automation server. And this is the first parameter. And along with the dispatch ID, the automation controller will also provide in an array of variant objects all the parameters that are provided from the script. And this is with all this information that the invoke function will then check whether you need to act on the property, which means get the value of the property, or modify the value by reference of the property, or if this is a method, and therefore needs to execute the method. So, or we can actually leverage introspection and reflection. So the way to leverage introspection is reflection in this case, because we want to execute dynamically Windows APIs, is by creating a wrapper around a Windows API. And in this case, it's named dynamic method. And this dynamic method is a pretty simple C++ class that just gonna store the function, the address in memory of a Windows API, the name of the function, and a dispatch ID. It will also expose one function called invoke that are gonna take as arguments the parameter provided from the script. And this invoke function will first pass all the functions to put that in a specific structure, and then we call an assembly routine called dynamic call, which will be responsible for actually invoking the Windows API and returning all the way back to the script the data of the execution. So the details of dynamic call will be in the next slides. So knowing that, we can actually start building a simple implementation of the get IDs of names. So we can have internally a simple table that's gonna be a table of like names and IDs, and we're just gonna, every time the get IDs of name is called, we're just gonna check the name and see if this is something that exists, and if it is, we just return the dispatch ID. Now on the invoke function, there's two cases. So in this case, I have a static dispatch ID, which is 0, which is gonna be used for registering a new function at runtime. And the name of this function from the script is gonna be DWT register. So we can either, with this dispatch ID, if it's equals to 0, register a new function, which means a new Windows API, or we can just simply use it to identify the dynamic method class that we want to execute. And once we get it, we're just going to execute the invoke function from it. So the important thing about here, when we want to register a new dynamic method and therefore a new wrapper around the Windows API, is the first thing is we need to ensure that the module is loaded. So if the user wants to execute a function, let's say message box W or message box A from user 32, we need to ensure that this module is actually loaded into the virtual private memory of a process. And then when it's done, we need to figure out what the actual address of this function in memory. So we can, from the assembly routine, we're gonna be able to directly call it. So you can do that with a get proc address, or I mean, you can create your own implementation by passing the portable executable header of the module if you want. Now that we have this information in the first part here, we're gonna use that to just like update two internal tables. One table that's gonna contain the list of all the dynamic methods, and just another table that contains the actual name of the function and the dispatch ID. And once we have those two tables updated, well, the next time the user gonna call the name of the method, the get IDs of names will be able to find this one and return the dispatch ID that then gonna be used by the invoke method to find the class, and execute it. All right, so now that we have that, and that we have an automation server, and that we know, or we can leverage that to dynamically register new methods at runtime, there is one last bit that is important and that is actually missing, is how from this dynamic method, this wrapper, we are actually able to call a Windows API, because this is what we want. And to understand that, we need to first understand what's going to be the calling convention and architecture that we're going to work on. So the calling convention is very important because this is what's going to dictate many things. And among the things, there's the order of parameter passing, whether the parameter are passed from right to left or left to right, which change quite a lot of stuff. But that all they're going to be, all they're going to dictate who is responsible for stack cleanup. So we're going to clean up the stack after the execution of a routine. And other stuff like name declaration of knowledge object, which doesn't really matter here. But in our case, we're going to solely focus on x64 assembly and the standard calling convention, because the standard calling convention is used by Windows API. The other reason why I focus only on x64 is because there's quite a lot of difference in terms of in assembly between x86 and x64. But with a little bit of work, I mean, the implementation of x86 shouldn't, be too difficult. So one of the major difference between 64 and 86 assembly is that 64 going to use a shadow stack for the first 4 parameters. So in 86, everything is pushed into the stack, and then the routine is called, and within the routine is just like popping the stack to get all the parameters one by one. Now in x64, instead there's a shadow stack, which is an automatically allocated 20 bytes space on the stack upon the call of any routine. And this is used to speed up a bit of the process of the passing of the first 4 parameters, because they're going to pass through registers instead of through the stack. So it's a little bit like a fast call calling convention fashion. And the idea here is when manipulating decimal data, the first 4 parameters from left to right will be passed through the general purpose register, which are RCX, RDX, RRT, and R9. Well, now if you're using floating point values, they will be passed through the streaming single instruction multiple data extension registers, which are XMM0, XMM1, XMM2, and XMM3. And for all the remaining parameters of 5th and onwards, they will all be pushed into the stack at RSP plus 20. So the stack pointer plus 20 bytes, because of 20 bytes before that are for the shadow stack. So now that we know that, or we can actually implement it, or we can actually call the function. So the dynamic method will pass the parameter, put all that into a specific structure, and then call the dynamic call routine. And what this routine in assembly, so I'm not providing any assembly code here because, I mean, I don't know many people that quite like that, and although for time reason. But the idea is we're just going to loop through all the parameters, and if we hit 0, because we went through all the parameters, we're just going to call the Windows API, which is just a simple call instruction. And then we're going to get the value and return that to the caller. Now, if the number of parameters is lower or equal to 4, that means we need to put the data into the register for the shadow stack, in which case we need to first calculate which register going to hold the data, so RCX, RDX, or R8, or R9, and then move to the correct register the data. Then we decrement the number of parameter. Now, if we are on the 5th and onwards parameter, instead of putting that into the shadow stack, we're going to have to put that in the actual stack. In which case, we need to calculate the location in the stack, which is not very difficult because we have the total number of parameters. And when we have this offset, we can just like move it to correct location, decrement the number of parameter, and loop again until we hit 0, in which case we call the API. So right, so let's just like quickly put everything together before going through the actual registration free part of it. So we have an automation server called DynamicWrapperEx, which has a class called CDynamicWrapperEx, which derives from the iClass factory. I'm not covering that here, but just think that it's a handy way to be able to not implement, actually, is not the correct term, but to create an instance of COM interface and COM component, which is perfectly fine because this is what we want. And this DynamicWrapperEx will derive from the iDispatch because we want an automation server. And this interface will also have the pointer, to an automation factory, which in this case is just like an utility class. Nothing fancy. We'll just be responsible for creating at runtime the dynamic methods, ensuring that all the modules are properly loaded and that we have the actual function address of the functions we want to execute. But the DynamicWrapperEx through the invoke function will also call the dynamic method, which will call the dynamic call assembly routine, which will call the actual Windows API. And by having all that, we are actually able at runtime from WVBS or GScript to create new functions, expose them to the script engine, the automation controller, so the script can call them and use them in order to call Windows APIs. So now we know that, let's quickly have a look at registration for activation, which is pretty important because when dealing with COM, most of the time, everything is going through the Windows registry, and everything is within the HKCL, so HK class root. And the thing is, if we want to directly modify that, we're gonna require high integrity, so we need to be admin. And at that point, I'm pretty confident that there's many other better ways to archive code execution. And the idea is when using functions, Windows API co-create instance, and by providing a GUID, a CLS ID, so the class, the GUID of a class, it will the function will just like go through a Windows registry, search if it exists, and then go through the inproc server 32 subkey, and from there it will identify the actual path of the DL into disk in order to just like load it and start using it. But again, we don't want to tamper with the Windows registry because there's quite a lot of way to actually, from blue team side of thing, to identify that kind of behaviors. So instead, we're gonna leverage the Windows side-by-side assembly technology, which is pretty old actually, starting from Windows 98. And the idea of this technology was to try to address a problem, which is the DL or dependency hell, because on Windows everything is DLs, and for a long time there were literally no versioning way at all. So if two persons was using the same DLs but with different versions, and the program was built for a specific version but the version doesn't match, that can lead to many problems. So SideBySide is actually offering a way to create assemblies, which are packages of resources. That's the easiest way to put it. And those resources can be DLs, but other stuff. And all those assemblies will be stored in the Windows SideBySide assembly store, which is under the Windows C Windows System 32, well, not System 32, C Windows Win SXS folder. So how it actually works, well, assembly and application have manifests, which are XML formatted documents, as you can see, and an assembly manifest will just be, the definition of every single resources within the assembly, and that can be, the name of the DLs, and although that can be the name of the classes, COM classes from within those DLs. So that's just going to be used to define what is within an assembly. And on the other hand, an application will use an application manifest, which will define all the dependencies and requirements of the application. So that's going to be, I want this, I need this specific DLs, and from this specific DLs, I need this specific COM class, which is exactly what we want and what we're going to target. Here we have an example where we want from within the DynamicWrapperEx DL, we want the DynamicWrapperEx class, and we provide the CLS ID of the class. So in order to have all of that working, we need to create an activation context, which will actually be responsible based on an application manifest to load from an assembly the DLs that are required. So there's two ways to actually provide an application manifest. There's the first one, which is to provide the path of the activation manifest. And there's another one is to provide it as a string at the buffer. And one of the big problem here is that assemblies are propped from within the Windows side-by-side assembly store, which require high integrity. So we don't have, as a low privilege user, the ability to create a new folder and to create a new assembly without high integrity privileges, which is a big problem because we're not going to be able to, load or assembly without having to register it. Fortunately for us, if we are providing the application manifest as a string at the buffer, instead of going through the Windows side-by-side assembly store, the assemblies are propped from the location of the temporary environment variable. So as we can see here in process monitor, the C script, when creating an activation context and providing the application manifest as a string at the buffer, will try to locate it from the C user, my user app data local 10 folder, which is the default value for the temporary environment variable value. And that means it's pretty big, because that means that at that point, we can pretty much deploy or ask automation server on any location on the system where we do have read and write access. So there's one COM object, which is Microsoft Windows ActCtx, which gonna be used in order to create an activation context. And here we have two examples, one in VBA on the right-hand side and one in JavaScript in the left-hand side. And we can see that the first thing we're gonna do is we're gonna first modify the TMP environment variable from the process from C script, for example, to a location where we do have read and write access. And then we're gonna use the Microsoft Windows ActCtx to actually create an activation context. And from this activation context, we're going to provide the manifest as a string, which is here from inside the manifest XML variable. And when doing that, the C script process and the activation manifest going to load the actual deals from within the TMP environment variable folder. And from there, we're going to be able to create our own COM object. We're going to be able to activate the COM object here, DynamicWrapperEx, without having to register it and to modify anything from within the Windows registry. So a full example now. So we have the same thing on the left-hand side here, where we just like change the TMP variable, create the activation context, activate the object, and now we can just use it. So from JavaScript, on the right-hand side, we can use the DWT register to register 3 functions from kernel 32. So virtual alloc in order to create memory pages, create thread to create a new thread, and wait for single object, which will be used as a synchronization function to wait for the end of the execution of the thread. And here we can use virtual alloc from the COM object, because we are registering it at runtime, in order to allocate a new memory page with, in this case, a read, write, execute security property. Then we can write the shellcode at the location and create a thread to this location. So actually creating a new thread that gonna points to this location and execute our shellcode and wait for the execution of the thread with the wait for single object. And actually from here, we're able from JavaScript to use Windows API in order to execute arbitrary shellcode. So what the actual limitation, because I mentioned that at the beginning. So some of the limitation is because invoke and get names are used for dynamically identify with expose and invoke some function. They are not able to pass every single type of data as parameters. So in this case, invoke is actually passing the data in an array of variant structure, which is quite messy actually, and big union structure of many data types. So in more concrete terms, that means that in the current implementation of the tool, there is no easy way to pass structure to Windows API, and that's the reason why there's you're not going to be able to really execute arbitrary Windows API, because APIs like create process, for example, that require a process information, startup infrastructure, you're not going to be able to use them. But there's a pretty simple workaround. Is you can, like I did with the DW register, you can just create static functions with static dispatch IDs that are going to be, an aggregation of APIs and functions. So you can use that. And actually, that's going to be the most reliable way to execute APIs, because you're going to have full control from end to end on what you're manipulating. Now, in terms of operational security consideration, it's important to note that the automation server will touch the disk. So even if you are fetching it from a remote location, so from a web dev location or SMB or something like that, it will touch the disk, because you're going to need to load it through side-by-side assembly loading through activation context. So you must avoid as much as possible known signatures. You must avoid, to embed shellcode directly into it or have static strings, because otherwise you're going to carry, signatures that then going to be, used by defenders to catch it. And now, from an analyst point of view, so more for the blue team side of view, analysts should be aware that the side-by-side assembly technology is not really in use anymore, because since Visual C++ 2010, this is not in use anymore. So that's the first thing. The second thing is, most of the time it's used for like C and C++ applications. So if it's in use from VBS or JavaScript, it's definitely dodgy and should definitely be investigated. Same thing for common read-writable folders like C users public or the app data folders, which are used quite extensively to drop files into disk and to load them. It should absolutely be monitored, because this is the common location where people just like drop stuff. All right, so that's going to be the end of this presentation. So you have my email addresses if you have any questions that you have, or if you have or if you have any question about that. You also have at the end my Twitter handle if you're more comfortable sending me messages on Twitter, and I will just spend time on answering questions if any.
Yeah, thanks, Paul. That was really informative. As I said, I had a little peek preview yesterday, but that was great to sit through that presentation, and I've definitely learned a lot today, and I'm sure the attendees have too. We've got a couple of questions that have come in, and so if we could just get these ones answered, that would be great. So the first one is it possible to use this technique to bypass the anti-malware scan interface, so AMSI?
Yes, so that's a good question, because AMSI is actually a big topic nowadays. So yes, it can, and for a very simple reason is when we are within a scripting context of VBS, VBA, or JavaScript, every single thing we're going to execute and every single buffers will be passed through the AMSI scan interface, which is an interface by the automation controller. But now if we move the actual execution or the actual component that is responsible for the execution of the code, this will be on our own object. And obviously, we're not going to implement the anti-malware scan interface, because it would be literally like shooting in on all foods. So yeah, I can be definitely used to shift the execution from something that is monitored to something that we fully control and that is not monitored.
That's great. Thank you very much for that one. As I say, if you've typed any questions into the question pane and you want to follow on from that, then please feel free to pop those in there. And as Paul said, if you do have any questions to send to him direct, then his email addresses are on there as well. Just another question, Paul, here. So based on the current design of the tool, would it be safe for operational usage?
Yeah, so I'm going to answer two questions actually here. So the first thing is, there's a question actually that has been in the chat. So the thing is, yes, the tool will be released at some point. I don't have any date at the moment, but it will be released, and there will also be more information in the form of maybe a blog post or a white paper. But at the moment, I don't really know in which form it will be. But there will be something, definitely. Although this is recorded, so you're going to be able to watch it again online. But the thing is, I would say yes and no. So the thing is, because everything is dynamic, it's prone to errors. But if you this tool have been more developed for science, let's say, and it's just like to prove a point and to fully understand how it works. But instead of like dynamically invoking stuff and registering stuff at runtime, the safest way to do it is just to simply create static functions, because at that point you have compilation time safety. And although you have the way, you have like a proper way to test if it works. So my recommendation is, yes, you can use it, obviously, but for maximum operational security, it's recommended to create static functions and to create directly your code in C and C++.
That's great. Thank you very much for that one. Another question here, and you might have to help me with this one, Paul. Can COM manipulation utilize, is it DLN-voke?
Yeah, so Dynamic Invoke is actually a technology that has been released a couple of months ago by some people in the InfoSec industry. So yeah, I mean, the thing is, when you create your own COM component, it's important to understand that if it's just a simple COM component or automation server, at the end, you're going to provide your own implementation. So you are pretty much free to do whatever you want. So you can create like normal Windows APIs, or you can use native Windows APIs, or you can, implement a way to directly invoke with a fast system call for call gates instead of leveraging on the high-level Windows API. So you're pretty much free to do whatever you want. In the current implementation, it will be used to register functions that are going to be either native functions, or the NTZW functions, or the higher level ones from Kernel 3.2 and that kind of modules. But yeah, you're completely free to implement it the way you want. There's, I mean, pretty much no limitation here apart from imagination and experience, I guess.
Lovely, thank you for that. We're running a few minutes over, but I'll just go in with the last question. So why using x64 assembly for the dynamic call function instead of C or C++? Well,
that's another good question. So the thing is, it's not really for the street cred, because assembly is always a bit of a pain to write. But the reason behind that is more necessity, because we want to implement a standard calling convention. We need to manipulate the stack, and we need to manipulate registers. And unfortunately, in x64, there's no easy way to do that without having to write assembly, especially with Microsoft technology, because Microsoft compilers for x64 are not providing intrinsic function, well, inline assembly. They're providing a lot of intrinsic functions that can be used to access data, but they are not allowing inline assembly. So we need to subsequently create our own assembly code. But ultimately, the reason is because, yeah, this is probably the most optimized and the best way to properly manipulate the stack and the register, which is definitely what we want here, in order to set up correctly in the stack and shadow stack all the parameter that then will be used to call the Windows API.
That's great, thanks, Paul. So unfortunately, we've come to the end of the webinar. So I just want to say a big thank you to Paul again for this presentation today. It's been really informative, and from the questions that have come in, I know that all the attendees have been finding it really useful. So as I say, please feel free to email Paul, or you can email us at marketing@crest-approved.org if you have any questions or you need to catch up with Paul on anything, and that would be really good. So thank you, Paul. Is there any last few words you would like to say before we end for the day?
Well, I'm just gonna say thanks to you again for having me today, and thanks again for all the previous presenters. And I'm really looking forward to the other presentation because I mean, by the look at it, is more interesting stuff. So thanks for all that.
Well, thanks for contributing to that, Paul. And as I say, we're going to take a short recess for lunch now, but we will be back with our next presentation at 1 o'clock, which will be towards active reconnaissance. And Oliver Fairbank from Orpheus Cyber will be giving that presentation. So I look forward to seeing some of you on that one. And then we have the rest of the itinerary online if you would like to have a look and see if there's any others that you would like to attend. So take care, everyone. Have a good rest of the day. And thanks again, Paul.
Well, thank you. Have a good day.